Hello everyone, welcome to another video session class. So in today's class we will study about aromaticity and synthesis or preparation of isoquinoline. So isoquinoline is a compound which is a fused ring system. Okay, that means two ring system are fused. So one ring is benzene and another ring is pyridine. Okay, so from the name we can get that it is the similar structure to the quinoline. So quinoline we have already studied. Okay, so iso means similar, quinoline means it is similar to quinoline. Okay, similar to quinoline. So in quinoline, what was there? The nitrogen, the here it is present at the second position, but in quinoline it was present, or it is present in the first position. Okay, so that is the basic difference between isoquinoline and quinoline. Okay, so let us start. So you see here I have given the structure, so 1 2, but there in the quinoline the nitrogen is present in the first position. Okay, so that's why it is 2 as an naphthalene, but the quinoline is 1 as an naphthalene. That is the difference. 1 means nitrogen, so in one position nitrogen is present, there is quinoline, and this is isoquinoline, so it is 2 as an naphthalene. That means at the second position nitrogen is present. Okay, so isoquinoline is the fused ring heterocyclic compound. So we already know it is the fusion between one benzene ring and another pyridine ring. Okay, in isoquinoline a pyridine ring is fused with a benzene ring. So I mentioned each ring atoms contain anhybridized p orbital which are perpendicular to the plane of sigma bond. So all these double bonded anhybridized p orbital, these are perpendicular to the sigma bond. Okay, that means single bond, and each atom is sp2 hybridized. So we know it is all the carbons or nitrogens are sp2 hybridized, and thus it is planar in structure. Okay, we know structure of sp2 hybridized orbital are planar. Okay, so total number of delocalized electrons are 10. So it is a total number of delocalized electrons are 10. So 9 from carbon, so 9 in carbon and 1 in nitrogen. Okay, so it follows Huckel rule, that is 4n plus 2 pi rule. That means 4 into 2, n is equal to 2 plus 2. Okay, that means 8 plus 2 pi, 10, total 10 pi electrons are there. That's why the isoquinoline is aromatic in nature. So that is about its aromaticity. So next let us see about the preparation or synthesis. Okay, so first reaction, it is name reaction Bistler-Napier-Lasky isoquinoline synthesis. So here what is happening, 2-aryl ethylamine. So why it is 2-aryl, 1 2. Okay, 2 position aryl group is there, that means phenyl group is there, and it is amine. So 2-aryl ethylamine react with acyl chloride or any acetic anhydride or acyl anhydride to form what, CONH. What is that one? This amide. So it will form a amide, and that amide will undergo cyclization in presence of P2O5. Okay, in presence of P2O5 or phosphorus pentoxide, and it will lose one molecule of water to undergo cyclization. So it is the cyclized. Then next what will happen, it will undergo what reaction, reduction reaction. So addition of hydrogen there, reduction of dihydro compound to isoquinoline. So overall it is forming the dihydro compound. Reduction means removal of okay, here removal of hydrogen is taking place, so it is ultimately forming isoquinoline. Okay, so next reaction, this reaction, that is preparation or method of preparation of isoquinoline, is the Pictet GAMPS synthesis. So here this is the modification of Bissler-Napier-Lesky method. Earlier was just the alkyl isoquinoline derivative, but it is fully aromatic, directly fully aromatic isoquinoline synthesis from 2-hydroxy substituted reagent. So here we have earlier we have used 2-aryl 2-aryl ethanamine, but here 2-hydroxy 2-phenyl ethanamine. So in presence of this C6H5COCl, okay, so ultimately it is giving this amide, and again in presence of POCl3 it will lose one molecule of water to give cyclization. Cyclization will take place to give 1-phenyl isoquinoline. Okay, so this is just the modification of Bissler-Napier-Lesky method. There in the Bissler-Napier-Lesky method we have one intermediate, that is, this is not saturated. Lastly it was saturated, but in this one what is happening, directly it is without any unsaturation, directly it is giving the fully aromatic isoquinoline. Okay, that is full with unsaturation. Next, Pomeranz-Fritz synthesis. So it is acid promoted synthesis of isoquinoline from benzaldehyde. So this is the benzaldehyde and 2,2-dialkoxy ethylamine. So it is 2,2. So in 1 2, okay, so 2,2 in 2 position there are 2 alkoxy group are there, so dialkoxy, so it is ethylamine because 2 carbon and 1 amine. So it is the reaction between benzaldehyde and 2,2-dialkoxy, whatever may be the methyl group or whatever, dialkoxy ethylamine in presence of acid. So it is written acid promoted synthesis. So it will lose water and 2 molecule of alcohol, respective alcohol of alkoxy. Okay, alkoxy, if it is methyl group it will be methanol, if it is R is ethyl group, so it is ethanol. Okay, so to give the compound isoquinoline. Okay, so that is the 3 method of preparation or synthesis of isoquinoline and about its aromaticity. So I hope you have understood. Thank you. No, one more method is there, I forgot to mention here. That is from cinnamaldehyde. So this is the structure cinnamaldehyde. Okay, we know it is the structure cinnamaldehyde. So condensation of cinnamaldehyde to form the corresponding oxime, then the oxime then heated with phosphorus pentoxide P2O5 to give isoquinoline. So cinnamaldehyde will react with hydroxyl amine to form an aldoxime, that is C double bond NOH. This is known as aldoxime. Okay, so it will ultimately this aldoxime or oxime then heated with P2O5, that is phosphorus pentoxide, to form quinoline. Okay, so that's all about this preparation or synthesis of isoquinoline and about its aromaticity. So I hope you understood. Thank you.